Okay, I think everything is working, at least on the first sight, which is good. Oh, I might need to add audio. Okay, and let's just put a little bit down there. Right. Okay. So I kind of felt like doing something weird for a bit. And in particular, this is actually a coding game, so it's not completely off topic for me. Let's see. Somehow Twitch is not wanting to catch up again, which I don't really understand what's happening there. Okay, maybe it's actually working. I don't know. No, I don't think Twitch is online. What the heck? Twitch is... And now it's fine. Okay. Streaming service is being weird. Cool. So let me just switch around the windows so I can see everything that I want to see. Right. Okay. So the basic idea of this is a coding game. There are a couple of coding games actually available. This is not the only one, but this one is actually pretty good. I did play this one quite a while ago. Oh, actually, I'm just noticed that I'm showing the FPS for absolutely no reason. So just a second. Okay, that's better. Right. So the story of this game is basically we are a software developer, or I guess like a chip designer, something like that. And I think we are supposed to be from the UK, I think. But apparently the only place where you actually can make chips and program chips is China. So here we are in China now. And we have a new amazing job. We also have a bunch of data sheets that I have already opened. So we get like a proper manual for all the stuff we will be working with. Let's just zoom in. So, yep, you know, all the information about the instructions and whatnot. This is actually meant to be printed and used like that, but well, I'm playing this on the stream, so that's not really an option. So let's see what's waiting for us in our mail. Dear new employee, thank you for joining Shenzhen Longtech Electronics Company Ltd. We aim to become the world-leading company in electronics industry and in a respected brand with products in homes, offices, and public spaces around the world. Longtech Electronics was founded on the following principles. Diligence. This means both diligence in your work and diligence in your life. When you encounter a problem, do not give up. Even if you are not talented, by working at it every day, little by little, you can achieve the goal. Wow, so motivational. Connections. The process of creating electronics is the process of creating connections between different components. In the same way, we do business by making connections with other people. Therefore, it is important to always be making connections in your work. Okay, that's not a bad idea. And salubriousness, I don't even know what that word means. An unhealthy mind creates an inefficient design. An unhealthy body builds a defective product. Follow correct eating, correct behavior, and correct thinking in order to maximize your potential. Ooh, so motivational. Please keep these principles in mind as you contribute to our efforts. I will, Mr. CEO, I will. So that's our CEO. There's another guy, Karl Teski, and I guess that sounds very Czech. So I guess that would be Karl Teski. I guess we will see. So, fresh meat, just kidding. Welcome to the southern China. It's alright, I suppose, except for the heat, smoke, and the lack of decent cheese here in Shenzhen. Still far better than any engineering geek I can find back at home in the UK. So he is from the UK, okay. I'm assuming you ended up here for similar reasons, Carl. Okay. This is Joe. Yo. So I heard you are our newest ace engineer who's going to kick ass and take names. Am I right? You've probably heard all about me already, but I'm the product guy who loves to find amazing opportunities and make deals happen. Let's do this. Indeed, let's do this. Greetings and welcome to the team. So this is Wu Lili. As you have already been made aware, we are on a major international expansion effort. We are very eager to see you bring your skills and expertise to our company. Yes, indeed. This is David P. Solomon. My name is David or something in Chinese. Okay. And I was brought on to help Longtech in its international push, though I have only recently moved here from San Francisco, yes, where I should point out there is a very vibrant Chinatown. I'm really loving it so far. It is truly fascinating to see a culture at once so ancient and so modern from up close. I'm sure we will be working closely together to create many successful products, indeed. And Ji Zhang, who doesn't use like English name in his email. Okay. Hello, my name is Ji Zhang. I am the chief staff engineer, your boss. I have not managed many foreign brokers before, so please understand if I make a mistake here or there. Anyhow, I will send you your first job shortly. It's kind of interesting that like our boss is like the last one to respond on the email chain. Like everyone else already chimed in and like our direct boss is like, yeah, I'm like the last one to respond. Okay, manual, yes, we already know about the manual, so that's the PDF that I have here. Okay, the first product that we'll be creating. Fake surveillance camera. Create a working design for this product to be histograms and leaderboards. Okay, I kind of love these jokes. It's like security camera fake. They need to make sure that, okay, like this is fake. Don't worry, like this will not be used for surveillance. It has two blinking lights. The first light blinks in a regular pattern. The second light is an internet light, so it should be blinking in a more random intermittent pattern to resemble data upload. Okay. As you will notice, the design is partially complete already. A previous engineer quit. Okay, good to know. It's always great to know that someone just quit when you join a company. Before finishing the assignment. Note the timing diagrams in the verification tab. When you simulate, your outputs should match those expected values as indicated. Let the simulation run until it has passed all the test cases and make sure you have a proper solution. I mean, at least we get the test cases already. Like that's kind of cushy, you know, like in a normal job, like you actually have to write those test cases yourself. And great confidence from Carl. I'm absolutely certain you will do better than the last person. Okay. Okay, let's go there. So, oops, open. Okay, cool. So, active and network are simple outputs connected to LEDs. Okay, so we have active and network, and these are outputs. Okay, Control the active and network outputs with fixed repeating signals as indicated in the verification tab. Okay, right. So the active one, it just goes up, down, up, down, up, down, up, down. And the network one, okay, I guess it's just a different timing. So it goes, what, 1, 2, 3, 4, 4 time units off, 2 time units on, 1 time unit off, 1 time unit on, and then it repeats, right? Okay, we can do that. But I guess let's just see. Right, okay, so stuff is happening, cool. Why is this so hard? I don't know. Okay, so we can write our code here. We don't really need to change this one because I guess, you know, this is already done for us, so cool. Well, we have this component here, so let's just plop it down. And I guess we will do it in a very similar way as this one. So we want to sleep for, be off for 4 time units, so sleep for 4 time units, okay. Then on for 2 time units, and then sleep for 1 time unit, then off for 1 time unit again. So it'll be the sleep 1, and then it repeats, right? Yes. Okay, let's see if we manage. No, I screwed up something. Okay, because here we are supposed to be on for 2 time minutes, right? Still not correct. Okay. Oh, because I'm still missing the and then yes, like that. Okay. So we are off for 4 time units, then on for 2 time units, off for 1 time unit, on for 1 time unit, and then we go back. So we are off for 4 time minutes and so on. Okay. Okay, cool. We have done it. And I guess we can make it faster, sure. Production costs are perfect. Power usage is perfect. I guess we can make it in less lines of code. And I think I did it better in my previous runs, apparently. So I did it in 7 lines of code. Well, okay. And if I remember, I played this a long time ago, and only went through like a couple of the puzzles. If I remember correctly, we get like better components, so we can then come back and try to fix our previous puzzles. Okay, why are we even here? That's a good question. Hi everyone, we have had a bunch of new signups this week, so let me reintroduce myself. I'm your host, Tilly Liu, and I run this fun little mailing list for expats in Shenzhen. I'm here to demystify some aspects of life and culture here, along with a side of helping of color commentary. Sometimes just the color commentary. Yeah, I get distracted. Okay. Today's topic is, why the heck are we in Shenzhen? No, really. Why are we here at all? I don't mean in the immediate sense. Sure, we all have some job or some businessy thing to do, but let's talk about the larger factors at play. We are here because Shenzhen been one of the fastest growing cities in the world for the past few decades, ever since it was declared a special economic zone back in 1980. We are here because, and really, the entire Pearl River Delta region, oh geez, that's hard to say, is a sprawling megacity wholly dedicated to trade, manufacturing, and services. A giant economic machine. We are here because what's possible in Shenzhen really isn't possible many other places in the world, certainly not at the same scale and cost. So where's all this capability headed, In the future, are we going to just make more stuff, more products and things until the world is buried in crap? I guess I'm asking, What is all of this incredible growth for anyway? Oh, good questions. I have some ideas, but it's a topic for another day. Yes, keep us waiting. Okay, new job. We are supposed to make a control signal amplifier. Create a working design for this product. Da, da, da. Okay, right. Our factory floor has some examples of older equipment that require control signals to be amplified. We had a device to adjust signals for this type of machine, but recently it was broken, smashed. Okay. This is an appropriate project to teach you about inputs. Smashed? Hang on a sec. What happened? Is everyone okay? No need to worry. Oh yeah, not suspicious at all. Okay, so let's make a design. So we have a control in, which is a simple input. Right, so we just get a signal level and we need to amplify it. And we need to amplify it basically just by multiplying by 2. Okay. Let's do that. So I guess we want to connect this to here, this to here. Let's see. So this is MC4000. MC4000. Right. So what can our MC4000 do? Okay. Okay, this is not the correct place to look for it. I want to look at what are the actual instructions. That was here somewhere. Ah, okay. Language reference, right. Okay, this is what they are looking for. Commands, labels, we don't care about those. Registers, okay, so registers. We have an accumulator, okay, good. Instruction operands. Okay, so we can move something from a register or input into register, right? We can sleep. Right. Okay, add the value of the first operand to the value of the accumulator register and store the result in a. Okay, cool. So I guess what we want to do is move P0 into accumulator. Then we want to do add accumulator to accumulator, and then move P1 move accumulator to P1. And I guess then we sleep 1. Yep, that seems to be working. Okay, lines of code. Apparently we can make it with less power. Okay. Looks good, thank you. Take care. Yeah, okay, cool. Please enjoy a game. My daughter is learning programming. She created a simple card game. Oh yes, I remember this. Would anyone like to try it and give some feedback for her? I put a link on everyone's desktop. This is not pushy at all. Like, hey guys, would you like to try a game from my daughter? I just installed it on everyone's computer. That's crazy. That's both more polished and far harder than I was expecting. Your daughter managed to design quite a challenging patience game. Maybe there could be an undo function. She doesn't think it needs an undo because it's actually quite easy once you develop some skill. She really takes after you. Okay, so we are supposed to go back to our desktop and win a round of this. Okay. Instructions. Okay. 3 suits from 1 to 9. Right. We can store cards there. Okay. Can be stacked. Alternating and decreasing. Okay. Uh, okay. Okay, so let's do this. So we can get back to coding. Wait a second, what is this one? There's a one here, there's a one here, okay. Right. Okay. Oh, we need to get to this one. Okay, the 2 I can place the 6. Not good. I think I screwed myself. Yeah, I kind of need the undo button. Apparently, I'm not good enough. I've totally forgotten how this works. Okay, let's try again. Yeah, like these, we need to basically collect 4 of them, and then they can just disappear. That's the. Oh wait, we have 3 of these, so I can actually immediately get rid of this. Okay, cool. And we can do these as well. That doesn't really help much, does it? Maybe it does. Okay. Just, 7, 6, 7. Okay. No, good. We are starting to get there. 5, 4. Okay. Yep. Yeah, okay, that's it. Oh, I need to flip this, but yes, okay, good. And yeah, I don't want to play this anymore. That was enough. Okay, don't speak Chinese. I'm sure there will be some interesting information here if I did. Anyway, now that you are up and running, I figure it's safe to let you use all the lovely parts we have available to us. Just be warned that not all of them are going to be useful for what you are doing immediately. On you go then. Okay, cool. So now we have all the components unlocked. That's good. In order to test some of our new manufacturing equipment, we need a pulse generator with certain requirements specifications. However, instead of buying one at the market price, I thought we could simply create our own. For this project, we will need to make conditional execution. Please continue your study of the language reference. Right. Okay. So we have a button. That's a simple input. Okay, we have a pulse. That's a simple output. When the button is pushed, generate pulses as indicated in the verification tab. Alting the button. Okay, so basically, as long as the button is pressed, we are supposed to basically just generate pulses. Okay. So let's see if I can make it with a simple MC4000. Maybe I can. So reference, what you are saying about this. So we definitely want some conditionals, right? So there's a bunch of tests. A is equal to B, A is greater than B, and whatnot. Okay, so we just need the tech, because we are just testing if the button is pushed, which means the value is 100. Right. So I think what we want to do is basically check if the button is pressed, then make one pulse, and then just repeat. Right? So let's just connect up the things. So if P0 is 100, right. Okay, what actually happens then? But that's the question. Yes, then we do the plus minus instructions. Okay. So if this is 100, then we want to do move 100 into P1. Otherwise, we want move 0 into P1, and then we just want to sleep 1, right? Yeah, no, it's a little bit more complicated, right? I want to make a full pulse, so this will be like this. Okay, so this sleep is actually shared. Actually, like this should be fine, right? Because I always reset to 0, so I don't really have to do anything else. Okay, should be fine. Yep. Well, apparently someone did it with 0 lines of code. Or is that... Yeah, no, that is 0 lines of code. Okay. Impressive. Great praise. It looks okay. It's suitable for our purpose. Amazing. Okay. Take an orbital selfie. Trip starts at just 89,000, or I guess 90,000. What's the currency? I don't remember. Dear adventurer, experience the stars and the earth as you have never seen them before. Enjoy the surprise and delight of true weightlessness. And of course, take pictures of yourself that nobody will soon forget. Did you know that there has never been a better time to take a trip into low Earth orbit? Demand is skyrocketing. Yes, that's why you are marketing so much, of course. And prices are cheaper than ever. Now is the time to get on this trend, which has been popularized by international superstar Cool Dad and many others. Tickets are going fast. Oh, so this is a Russian. So this will be Rebels. Oh, how do you pronounce that in English? I don't know. Animated esports sign. Okay. It begins. I got us an incredible deal with major esports personality, the Solid Steel Gamer. Her teams contracted with us to make light-up signs that actually animate for her fans. As long as we can keep the cost down, they're going to want tons of these to hand out at matches. Looks simple, just a few states. Okay, let's see if it indeed looks simple with just a few states. Well, we get a bunch of inputs and stuff, so let's see. So click 0 and click 1 are simple outputs connected to display segments. Okay. Drink 0, drink 1, and drink 2 are simple outputs connected to display segments corresponding to drink animation. Okay, control the display segments with fixed repeating signals as indicated in the verification tab. Okay. So clicks are just pulses that just go opposite to each other. Okay. Right. So this is all just periodic stuff, right? Yes. Okay, I'm getting the feeling there's some Boolean logic involved here. Because if I do OR of these two, I get the negative of this one. Okay. And obviously this is an, inversion of this one. Okay. So I think what we actually want to do is generate these two pulses, the drink 1 and drink 2. And then just somehow generate the drink 0 out of that. Okay, let's see. I remember that there were some interesting components here. Digital I/O expander, I don't care about that. Logic gates. One input, one output. Okay, let's just see how that works. Which one was it? This was this one. Yes. Okay, let's just, oops. Let's just see what happens. So oh, we need to actually sleep. So we are sending a signal, this is not sending a signal, right? So, okay, this is being 0, good. So this is an inverter, okay. So then we said we want an OR gate. Right. So that was the G32. Right. And I guess one more inverter. Right, so we said that drink 0. Okay. So let's do it like this. So drink 0 will be, oops, oh, not like that. I think I will need this. Okay, something like that, I guess. And we still need to get these two out. Now the question is, can we feasibly control everything with one component? I don't think we can manage with a single MC4000. Well, okay, let's see. So we are writing into click 0. So that one starts at 100. Then yep, so that works. So click 1 and 0 is okay. Now can we make this work? So how many 10 minutes is it? This is 2, 4, 6, 10 minutes. I guess. I mean, we can definitely make it work with 2 MC4000. I'm wondering, because this thing has... Oh no, this still only has 2 analog outputs. And we need to control 3 different things. So, okay. I guess another MC4000 it is. Okay. So what do we, so we want to sleep for 6 units, I said, right? So 2, 4, 6. Then we want to move 100 into P0. Sleep 1. Then 0 into P0 and 100 into P1. Sleep 2. Then back to 100 into P0 and 0 into P1 and sleep 1. Shoot, I actually have trouble fitting this into this one either. Okay. I'm missing 1 line. Okay. Can I make this? I mean, what we can do is actually let this one turn on for 4 units. Okay, like this. And we can do one more little negation here. So the thing is, I can just turn off the drink 1 when the no. Yes, I want not the negation, I want XOR, right? So this is the LC7086, this one, and I'm definitely running out of space. Okay, alright, let's just relay out everything. So this one goes like that. Okay, that's fine. Okay, let's just do this. Shoot, not enough space. This is like the third puzzle or something. Okay, so this will go somewhere here. This one, okay, this one still needs to take this and this. Shoot, okay. Oops, not what I wanted to do. Okay. So let's put this like that. Yeah, you cannot connect things to themselves. No, but that's fine. Okay, that's not a problem. I still have a problem with the layout. Oh, damn it. How do I... Okay, this is obviously there. Yeah, right. Okay, let's do it. No, inverting it doesn't help me. Okay. Still need to get this one somehow in there. So this needs to be 2 away from the border. Okay. Okay, that will work. Okay, good. Is this correct? Wait a second. What? Drink 0. Why is string 0 inverted? Okay, I must admit I'm not sure what happened there, but apparently it's working now. That was weird. Oh wow, I actually beat my own personal record. The end result looks great. I love the way it looks like the solid state gamer is really clicking the mouse button and drinking her soda. This is going to be huge. Well, I hope so. That's, I guess, how I get paid. Drinking game scorekeeper. Okay. The Baron von Schnaps is in the house, y'all. I was out drinking last night and I met someone from the company that owns this brand. there's a drinking game they are promoting that's hella fun and off the rails. I made a deal to supply them with little personal skull creepers they can give away at their events. Wait, what's this game? What counts as a point? What would be a foul? Surely not individual drinks. I don't remember the actual rules. Okay. We have great co-workers, like this is such an amazing environment. Okay. Wait, let's actually read what they are supposed to do. Point and foul are simple inputs connected to buttons. Okay. Point and foul. Okay. Display is an XPath display output corresponding to a numeric screen. Okay. Okay. Okay, so basically point is increment by 1 and foul is decrement by 2, but never go below 0. Okay. Can we make it with this one? I wonder. Well, let's try. Oops. So we will always do move accumulator into x1 because that will be our output. Now the question is what exactly we will do with our input. Okay, assembler. Let's see. Okay, this that I was looking for. So what are the okay. We have a bunch of tests. Oh, that's it? Oh, geez, okay. That wasn't very descriptive. I guess what we will have to do is go to negative and then just check if we are negative, and if we are, just set it to 0. I mean, okay, so if we have a signal on P1 which is a point, then what we want to do is just what was it? Was it add? Yes, add 1, right? If P0 is 100, then we want to sub 2, and then we want to test lower than. Okay, so we want to tell okay, TLT accumulator 0, and then just add 1 because we cannot. I guess we can go to -2 from 0. Okay. Well, the good thing is I have just glanced. Yes, this beautiful instruction note. If the value in accumulator is 0, store a value of 100 in the accumulator, otherwise store a value of 0. So we just want to do not. And I guess that's it. Yeah, seems to be working fine. Yeah, super efficient on lines of code, power usage could be better, production cost is perfect. Okay. Alright. If you can't remember the rules of the game you are playing, how sure you can be you actually made the deal? Okay, because they sent us the case with a variety of flavors. It's very tasty stuff. Come try some. It's already too late for me, but you can still save yourselves. Heed my warning. Do not drink of the Baron von Schnaps by then. See you in the next life. Okay. I will just quickly run to grab water. Be right back. Okay, and I'm back. And we have an email from the Shenzhen days. Hey y'all, well, I'm not reading that. Sometimes it's tough to represent how word really sounds in text, huh? Take for a totally random example, Shenzhen. How do you say it? What's the ZH doing there? Can you just ignore the H? Spoiler warning, you can't. ZH is its own sound in Chinese. We don't have time to go into all the fun foibles on pinyin, the official romanization system for the Mandarin Chinese. So let me just give you a little shortcut. Say Shen Yen. Maybe not like that. Okay. You know, like you are talking to your best friend, Jen, or Jen, Shen Jen. Okay, well, that's kind of what I was saying. And well, then you are probably closer than you were before. How's that for confidence? I will do one more. The Chinese yuan is the currency here. That word is one syllable. I hear people go yuan or yuan, and wow, that's kind of painful. I'm not sure how to fix this quickly. How about trying to say yuan really, really fast? You are still making two sounds instead of one, but maybe it's closer, maybe. By the way, we use as a currency symbol, which you might associate with Japanese yen. Yes, that's it. It's also the Chinese yuan. Look, don't you dare give me side eye if you come from a place that uses dollar sign, because you do mean Hong Kong dollars. Australian dollars, Canadian dollars, yeah. At least we can probably agree that this means Alkash, yes. Anyway, now you are wandering around Shenzhen, I guess, buying things in Chinese yuan like you are a super pro that you are. Pronunciation can be tough, but it's worth putting in the effort, ain't it, y'all? Okay, and we are building a rubbish audio thing. Cool. So contract comes in to build a piece of audio kit. Sounds fun, right? I've always liked audio. This client promises that their little box will deliver crisp highs and booming lows, all in perfect balance. Then I see their advert happens to include the match-valued algorithm that powers this thing. Go on, take a look yourself. I should mention I put a copy of said advert on your desk. Just look in the pile of papers marked supplement data, since that seemed most appropriate. I should also mention that we still have to do this as it is. Work and all, even when you have to help a dodgy American company market rubbish like this as a premium kit for audio files. Okay, well, first of all, yes, okay, so he actually meant in here, supply, no. Oh, that's 2 piece. Okay, makes sense. Yes. Incredible sound at breakthrough price. Sounds impossible. Now sounds like harmonic maximization. Okay. Right. So, yes, it's an amazing formula. So, audio out is audio in minus 50 times 4 plus 50. Okay. Yeah, bunch of mumbo jumbo. Right, so let's get into that. Audio in is a simple input, audio out is simple output, maximize is a simple input connected to a switch. Okay, so when the switch is on, then we need to maximize the audio. Okay. Right. Well, okay, let's just first... I just want to write the algorithm, so that was... So we always move the data into accumulator, and then I guess... we need 3 simple inputs. This one is just... I wonder how to make this. Because I don't think there actually is... Yeah, I think we have these three different chips. We have this one, and this one. But all of them have only two simple inputs outputs. They're even saying like we should just use these two. So how do I make that work? Interesting. Well, I guess let's just first write the thing, assuming I will figure something out, and then, yeah. So this will be our output. So okay, there will be some sort of test here. I don't know exactly what test. Well, let's just do something simple like this for now. And then if this is on, then we just want to do the modifications. So it was, where's the formula? So audio in -50. So let's just write it very simple. I don't think this will be the most optimal way to do it. Do we have a multiply operation? Yes, we have a multiply. What exactly does it do though? Multiply the value of the first operand by the value of the register. Okay, so then mul4. Back to the sub. Okay, let's just do this. I should have done that at the beginning. So sub this times 4 plus 50. Okay, so then just add 50. And then I guess output accumulator into P1. There are these things, right? But how exactly do they work? So this is DX300. DX300. That's kind of the opposite of what I want. Yeah, because this writes only hundreds and zeros. And I don't think there's like an opposite of this, right? No, there isn't. Oh no, so I can actually read... Ah, okay, so I can use this one. So if... where is this port again? It's x0. So if x0 is 100. Okay, let's see. Oops, we are not sleeping. That's a mistake. Okay, let's... No, that didn't do anything. So this is not... Okay, let's just see what the value is. So move x0 into accumulator. This will be wrong, but it is. So okay, so this is 1. Okay, so if x0 is 1, okay, now it works. Cool. Oh, cool. I'm happy with that. Very low production cost, very low power usage. I guess it could be slightly better. And very good lines of code. Holy crap, this thing is awesome. I hooked one of these babies up to my stereo at home and it blew the speaker clear off. That's the job, no question. Amazing. Okay, some self-driving cars crashing. A rogue loop is defined by the court as a state where the self-driving car appears to disregard humans and continue to drive around, refueling itself when necessary and ignoring orders to stop. That's amazing. Okay, let's continue building stuff. Passive infrared sensor. Okay. I am in the process of setting up closer ties up with global firms, and I'm working to secure higher profile work for our company. The first result of these efforts is a contract to create an infrared sensor. This allows us to participate in the booming market for passive monitoring stations to detect illegal activities. Illegal carbon emissions, illegal growing operations, illegal immigration. If it's against the law and it generates heat, we'll detect it. Okay, it's starting to turn dark. Okay. So what do we have? We have time, which is simple input connected to the clock. Okay. So that would be this one, I guess. Okay, so this is just monotonically increasing. Okay. We have a sensor. Right. Alarm is a simple output connected to a simple alarm, right? When the current time equals okay. So basically when the time reaches this number, we should turn on. When it reaches this number, we should turn off. And as long as we are on, we should just sound the alarm as long as the value is above 20. Okay, so we'll definitely need something like TGT P020. Is it crater at or above? Wait, so we need to go back to the language reference. Okay. Greater than, lower than. I think then we want to test lower than. Yes, because not less than. Okay. So we want TLT P020. Okay. So let's just ignore the arming for now. So then we move 100 to P1, and otherwise we move 0 to P1, and then we sleep 1. So this should work with the caveat that we do stuff when we are not armed. This is not working. Well, because I did it the other way around, of course. As usual. Okay. So I think, well, we cannot really make it inside of this thing, I don't think. We need at least 2 chips. Yeah, we need at least 2 chips, but what we can do is basically put an end here. And space issues again, damn it. So, right, this goes here, this goes here, and this goes here. So this thing will return 100 on P1 as long as we are armed. And then if we end it with the P1 here, then we get the signal. Cool. So, our initial state is, I guess, disarmed, right? Yes. So what I want to do is move the... I guess I don't have to move anything, so if the time, so P0 equals X0, then move 1, I guess 100 into accumulator. If time is X1, which is off time, then we move 0 into the accumulator. And then we just move accumulator into P1 and sleep 1. No. Wait a second, this is again doing wrong stuff. We want to look at... which component is this? 08. And okay. One output AND gate. Oh, because this gives both normal output and inverted output, and I keep using the inverted one. Okay. Silly me. Don't read my documentation. Okay. Yeah, lines of code. This can be done better for sure. Yeah, I think the MC6000 yeah, maybe. No, I'm not super convinced if that would be actually better. I mean, again, we are kind of running out of inputs. That's the core issue. and outputs on the chips. But I mean, clearly, when I run the test, there is a better way to do this. Like, there's no question about that. Yeah, like better lines of code, better power usage, better production cost. Well, at least when I played this last time, I didn't make it better, which is kind of, well, I don't know if that's comforting or anything, but it is what it is. Okay, just letting you know the design for the infrared sensor component was well received by our partners and is set to be integrated into a number of products currently under development by various defense and security firms. Obviously, our performance here opens the door to more jobs of this nature, so thank you for contributing to Longtank's future. Hang on, we are becoming a defense supplier? Yeah, she didn't really talk about that in the first email. Working remotely. Note that I will be working remotely today and maybe tomorrow, just in case you are looking for me in the office. That's weird. I thought you got back from your trip yesterday. I did. I've been stuck in the traffic jam on the way back from the airport since then. Wow. You have been in the same traffic jam for over 24 hours? When a city grows as fast as Shenzhen has, it's natural to expect there might be some strain. I'm fine. I have food and water here. Maybe next time a virtual meeting is better. Amazing. Okay, virtual reality buzzer. Hi all, apologies for the personal side here, but I have met this wonderful girl named Xiaomei, and well, to make a long story short, she's set to move in with me the next month. There's just one small issue, and it's something I thought maybe we could create a product to help with. See, when I'm doing my VR sessions, it's easy for someone to sneak up on me because I can see or hear them. Awkward to say the least. What the heck is it doing in the VR? This inspired me to think up a product. A simple vibrating buzzer that attaches to a VR headset and so it can be felt even during the most intense sequences. Okay. Connecting that to a radio controller, I could place the button outside of my study and Xiaomei could buzz me when she needs me, with no chance of me being caught by surprise. What do you think? I'm sure plenty of other VR enthusiasts might find themselves in a similar predicament, and this is a solution inexpensive enough to be an impulse buy. Congrats, David, and what is he saying? Note about the radio chip you'll be using. Normally, reading XBus causes the microcontroller to block until data becomes available. However, this radio has a non-blocking XBus buffer. The non-blocking buffer will immediately return a value of -999 when no data is currently available. Should make it easier. Okay. So Rx is the input. Buzzer is a simple output connected to an electromechanical buzzer. When a data packet is received over the radio, read it and execute the corresponding command. Right, okay, so if we get a 1, we should turn on the buzzer, which is just a simple pulse. When we get a 0, we should stop. Okay. Okay. So okay, no, so we need to actually store the data, because if we want to do multiple tests, we would basically read it and then get -999. So we need to move the data into accumulator and then we can test it. So if it's 1, then we want to start, and if it's 0, then we want to stop. Huh, okay. That's not the easiest thing to do. I'm wondering if we need a bigger chip, because this one has a second memory place. This one, no, this one we don't care about it. We could make it with 2 chips, but it's slightly more expensive. So this chip costs 5, the small chip costs 3, so having 2 of the smaller ones is actually less efficient. Okay, so let's make it with the bigger one. So we move the X0 into accumulator, then we test if the accumulator is 1. If it is, then we move 100 into data. If it is 0, then we move 0 into data. And no, shoot, okay. This will be much easier with 2 of them. Because basically what I can do is no, I cannot. So I was thinking I could just have one generating like a non-stop pulse, but that's not how it works. We want to start the pulse the moment we get a 1. Yeah, so I basically kind of want to have 2 states inside of the chip. Like I'm buzzing, I'm not buzzing, right? So yes, how did there's a way to have labels. Right. Jump to the specified label, right? Right. Yes, something like this. Okay, so we want to have a buzzing and not buzzing. So if we are buzzing, then what we do is well, first of all, we need to test if X0 I wonder if this will work. Is it like this? Yes. So if we get a 0, we stop buzzing. Sounds reasonable. If we if we are not buzzing, then we do the opposite. Otherwise we just sleep 1. Right, and here what we want to do is I guess we want to do accelerator move 0x. So the first time we wake up, we move 0 into accumulator. Because then in the buzzing, what we do is we do not as the first thing, then the value would be 100. Then we sleep 1. And I guess like that. But we want to start in not buzzing. Right. Okay, that didn't work out, so let's see what broke. So we have a 0 on the data buffer. We check if it is 0. We jump to not buzzing. Oh, but we forgot to... Yes, so... Move 0. We need to stop. Okay. Yes, okay. Now it's fine. Yeah, I don't think this is the most efficient... Yeah, very obviously. Yeah, this is not good solution. It's very expensive, a lot of power usage, a lot of lines of code. So you can make it with 3 yuan. So I mean, you can make it with a simple chip. Huh. Curious. Okay, no, I don't want to continue editing actually. We can come back later to like optimize some of these. Wonderful. This is exactly as I had imagined. Good. Prototyping new ideas. Sometimes a decent product idea falls out when you are faffing about with chips and code and the like. So I've set up an empty prototype board for us to experiment on. On you go then. Chips. We can hold the buttons. Yeah, I don't. So I know what this is. This is basically you get an empty space to play in, and yeah. Yes, I made the game. Yes, of course. Okay. Yeah, not really reading those. Right, wireless game controller. I'm wrapping up a project to make a game console and could use some assistance. Before you get too excited, it sounds far more fun than it actually is. The console is just a tiny super cheap box where we are making for sleep cubes, the big Japanese capsule hotel chain, to stick in every pot. The games will just be some free draws they find, I'm sure. At any rate, I have got mostly done. I just need a module for the little wireless controller that comes with it. I ping you, you tell me what's going on. Nothing much more than that. Right. So we have X and Y. So that's a joystick, okay. A and B are simple inputs connected to buttons, okay. Radio RX is non-blocking X-bus input connected to radio receiver. And TX is the transmitter, okay. Okay. So you basically need to return XY and then one of these 4 values, right? Okay. So xy we can return pretty easily. This is the interesting part. Okay. I'm kind of thinking this could help me, but I'm not sure. I will need a lot of simple inputs. Okay, so these are just analog, right? Right. Yeah, so I think I will really need this. Something like this. And yes, I will need a big chip. Right. So when we get a signal on Rx, we need to oh yes, like this. Okay. So if we get a -1 on x0, then we want to start sending. So we want to send P0 into x1. We want to send P1 into x1. And then we need to manipulate the x2 so we get the... Yeah, there was a digit operation, I remember. Digit. Isolate the specified digit in the accumulator register and store the result in the accumulator register. Okay. Okay. So since this will just be on if it's on, so what we can do is digit of x2 no, that's not how it works. So first we need to move x2 into accumulate register. Then we want the first digit. And the problem is I have no idea which of these will be what. So let's just go there. So what is the value? Let's... So A was just 1 and B is 10. Okay. Right. So then we want digit 1. What was the... Yeah, so A ends up being just 1, B we want to multiply by 2. Okay. Then we want to move accumulator into data. Then we want to again do this. Now we keep the digit 2, multiply by 2, and add data. And yeah, that's it. Then just move accumulator into x1. No. Thing is, all of this we want to do only when we got the signal right. Okay, seems to work. No, doesn't work. Okay, what the heck? So what? Okay. Right. So we have the digit 1. Okay. Digit. Oh, this is 0 based. Right, of course. Of course it is 0 based. Okay. I was reading the third digit. Yes, okay. Now it works. Yeah, not the best. Cheap, but not the best. Thanks, mate. I owe you one. You have just helped make thousands of dead, tired salarymen marginally happier. That is, if they actually find the console and use it to play a game before passing out. Oh, that's so depressing. Feel the connection and get ahead. Are you lonely? Do you feel isolated and disconnected from the world? Yeah, okay. Okay, laser tech equipment. I think I will make this the last one for today. Please don't blame me for this. I have a friend, more like an acquaintance really, from a while back, many jobs ago. He's always been a bit of a nutter, and I guess what happened was he made a decent bit of cash with an app or something and decided to retire from the programmer's life and build a laser tech arenas for the rest of his days. That's not the worst of it. He's scaling his franchise to be the Asymplex. In any case, he wanted to see if we could make some scorekeeping variables for it, and I said yes. I'm not entirely sure why. I suppose in the unlucky event his arenas do take off, it will look brilliant in hindsight. Okay, when it's done, we should try a match in the office. Laser tag looks like so much fun. A lot of simple inputs, either on or off. Too many for a microcontroller on its own, but a good use for the DX300. Yes, so we already used that one. Okay. Yes, so this is, yeah, that's plenty of inputs indeed. So heat is a simple input connected to an array of laser sensors on the west, right? Okay, so heat is just when someone gets hit. Respawn is a simple input connected to a quit connect, yes. Alive. Okay, alive is an LED. Yeah, so when a person respawns, they are alive. When they get hit, they die, then respawn, right? Okay, makes sense. Trigger and reload are simple inputs, right? Fire is a simple output, right? When a player is hit. Okay, so when you are hit, you are not alive. When you are respawned, you go back to alive, right. When a player reloads their gun, whether alive or not, their ammo should count. Okay, so reloads doesn't matter if you're alive or not. When a player is alive and pulls the trigger and has ammo remaining, the gun should fire and the ammo count should be decremented by 1. Right, okay. So this is important. So when you press the trigger and you are not alive, you don't even decrement the ammo. Okay. So I guess we will actually want to have an end with alive and fire. This will be actually our fire, because when not fire though, trigger, right. Okay, I already see that I will have space issues in this one for sure. Okay, so trigger, and this will come from all the way around here. Sure, let's make it like this. Okay. Right, so we only see trigger if we are alive. Okay. And then we decrement the ammo. Okay. So reload should work always, so that's fine. Okay. So I guess this one actually will go here. Yes. Oh no, because this only happens if we have ammo. Oh. Okay. So how do I make this? So I will definitely need to actually write the alive at some point. I wonder, actually, it would be kind of convenient to have just like inputs and outputs, right? So hit and respawn, those are actually inputs. And I guess the other input is trigger and reload. And fire and alive are actually outputs. Whew, okay. Right. Okay. Yeah, space issues again, of course. Okay, this can be a little bit better laid out. Sure. So here I will need okay, this and yeah, I don't need that. Okay, so the modified trigger and the reload, those are our inputs. The hit and respawn, those are the other two inputs. And alive is a simple output, fire is a simple output. Okay. Then I definitely need... Yeah, I don't have enough states for that, and I'm pretty sure I will need this big one anyway. So this will go here, that's fine. This gonna go here, and I need to connect this to here, for example. That's fine. Okay. So now the question is, do we start with 0 ammo or full ammo? Reload. Okay, so here there's pressing of trigger, but nothing is happening before reload. So okay, so we start with 0. So if we get a reload, so if yeah, okay, this one is getting complicated. So on reload, we want to reset a counter that will be our ammo. So I guess what we want to do, we want to set accumulator to x2, right? On trigger, we want to decrement accumulator. Well, and we want to fire. Right. On respawn, we want to P2 200. Actually, this will be just a pulse. Right. On hit, P2 0. Okay. So that part is actually very straightforward. So what I can do, so this will be, what's the number part? Take 300. Okay. So P0, so the bottom one is a so the bottom one is a 1. So it goes 1, 10, 100. Okay. So if we get a respawn, so that will be a 1, then and 10. Okay, so this should just track whether... and of course we need to sleep. So this should just track if the person is alive or not, and it's not working correctly. Okay. Then I guess this would be the other way around. Oh yes, because I moved this to the wrong thing, so this will be here, right. Okay, so we're correctly tracking a live state, that's good. Now, on reload. So if x3 is 100, no, because this is p0 is 1, so if it's 1, then we move x2 into accumulator. If it is 100, then oh, I wonder, I'm actually not sure what happens if we overflow. Because one thing I could just do is the closest allowed value is stored instead. Okay, so it just gets clamped, it doesn't... Okay, so what I can do is basically just do subtract 1, and then if oh shoot, but I want to do like yeah, okay, so I have the ammo tracking, but the problem is I'm still not shooting. Yeah. Okay, so how the heck do I do the shooting part? Yeah, the tricky part is what I basically want. Yeah, something like this. I want to jump to shoot. Oh, how do you do the labels again? I keep forgetting. Oh, the other way around, of course, like this. So if I have ammo, I want to move 100 into P1, then sleep 1 cycle, and then I'm out of space. Okay, I think I can slightly save on space by like making this inverted, but I don't think that will help me in the long run. Okay, can I save on something here? This I need, like there's no... Okay, but these two things are basically independent of anything. So what I'm actually thinking, I will just slap one of these in here. And that will be fine. Well, except for the usual space issues. Yeah, basically this one will just drive whether the person is alive. So I guess now I can use maybe I can use a small one, yes. So let's just optimize a bit, right? So this gets connected to here. And was that it? I guess it was. Okay, so if x0 was 1, so let's reload. We move x1 into accumulator. If it is 100, then we move okay, then we want to do jump to shoot, and we okay, yes, other way around. So then we jump to done, and done will be just sleep 1. Okay, so if we are shooting, we sub 1 from accumulator. Then if accumulator is greater than... I'm running out of space again. Oh, this will be so expensive. I think for now I just need to use the big chip. I'm sure I can do it with the small ones, but I think it's just too late for me today for my brain to work properly. Okay, so let's do this. Right. So, right, so x2 goes there, right, this is fine. So if accumulator is greater than 0, then what we want to do is actually shoot. So we want to move 100 into fire. We want to sleep 1, and we want to move 0 into fire, and then just be done. Right. Does that work? No. Because somehow we are not firing. Oh yeah, because somehow we are not reloading. What the heck? So if we could reload... I thought P0 was... Yeah, P0 is 1, so why is this not... Wait, why is trigger... Okay, yes. No. What the heck? um... Okay, what's the problem? So at this point, we have 5 bullets. Okay, so now we shoot, right? So 1 bullet goes away, we shoot. Okay, 2nd bullet, 3rd bullet, 4th bullet. Ah. Yeah. I did the other way around. Now it's fine. Okay. Off by 1 error. Yeah, okay, pretty expensive. Not horrible power usage and not horrible lines of code. It's actually, I thought this would be way worse than it actually ended up being. Okay, well, okay, let's read this. Joe, it would be great if you focus on business instead of constantly suggesting distractions. Also, I would destroy you. Just got words from my friend. He's purchased a building for his first, I can bring myself to write it out, his first location. Not sure I want to imagine how much of his retirement he's put into it. It's always nice to have a dream, but sometimes there's a reason you shouldn't pursue it, you know? Okay, so it has been 2 hours. I think that's good enough for now, and I will definitely be back with this at some point, and I will also definitely be going through the previous puzzles and trying to optimize them. Well, thanks for watching, and see you sometime later.